SwayamPrabha. Digital India. Educated India. SwayamPrabha. Digital India. Educated India.
Hello and welcome to the course on air transportation. Have you ever wondered how the large number of aircraft which are in the air at any given point of time, some approaching a runway, some taking off from a runway, some overflying an airport, how this complex traffic is controlled, monitored and managed? So, today we are going to look at some principles of air traffic management. This is a very complicated subject, and to give a proper justice we need large number of lectures, but I will try my best to condense all the important information mostly relevant to the principles of air traffic management into this 1 or 2 lectures. So, let us start with the outline of today's session. We will first have a broad overview of the objectives of air traffic services. Then we will look at how the air traffic services are divided into certain units, so that the work can happen with coordination between various units. Remember that this classification is not something which is globally acceptable. There could be differences in the units. So, whatever you see will mostly be applicable to what is prevalent in my country, that is India, but very similar schemes have to be followed globally, because air transportation is something that happens at a global level. Therefore, it is the duty of agencies like the International Civil Aviation Organization or ICAO to ensure that there is a harmonization of air traffic services across various sovereign nations. So, while the broad principles are going to be the same, the specific details may be a bit different from country to country. So, this may please be considered only as a general overview and not very specific to any particular country, although my knowledge and my information is mainly drawn from the ATM services provided by my country, that is India. We will look at the 3 pillars of ATS on which this whole edifice stands. If one of these 3 pillars becomes weak or inoperational, then the whole system will collapse. So, all 3 of them are equally important to support the edifice. One of the important component for providing information about the location of the aircraft, and also in some cases more than just the location, the identification and the distance and the angle at which they are, is given by the radars. Radar, as you might know already, is an instrument which is a short form for radio detection and ranging. That is the full form of radar. Air traffic services use a variety of radars. We will look at 3 or 4 types of radars. Then there are certain rules of the air within which all air traffic has to operate. Those rules will be discussed very briefly, And then the most important aspect which we need to realize is separation of the flying agents, so that there is least probability or no chance of communication, and we have to maintain certain minimum gap, both vertical or lateral or radial or a combination between various flying agents. So, we will look at separation minima, and we will also look at things like separation minima which are controlled because of the wake turbulence. Coming to the objectives of air traffic services, the key objective of this particular agency is to prevent collisions, and these collisions are not only between two aircraft which are flying in the air, but also between the aircraft and any obstruction or obstructions in the maneuvering area, and these also may be moving. There are a variety of vehicles which are moving on the tarmac of an airport. Some of them are fuel bowsers to fill up the empty fuel tanks of an aircraft. Some of them are the passenger buses which are used by people like you and me, the passengers at many airports, to board the flight, or after landing you deboard and then you come to the terminal to pick up your baggage and to exit the airport. Then there are other vehicles, service vehicles, electrical trolleys, pneumatic trolleys, hydraulic trolleys. There is a plethora of equipment which is moving on the surface of the maneuvering area, and there are aircraft which are coming and going. So, collision not only between two aircraft, but also between aircraft and various obstructions, various moving elements onto the airport. Every airport also has certain instruments, certain facilities which are fixed, and we also would like to ensure that there are no collisions between those obstructions and the aircraft. After preventing collisions, look, there is an order here of importance. The primary duty of an air traffic service is to ensure that there is no collision. Once that is ensured, the next important task is to expedite and to maintain the orderly flow of air traffic. This is not only from safety point of view, but also from economic point of view, because if aircraft is not able to fly, or if it is in the air and not able to land, it is going to consume a large amount of fuel. So, therefore, it is important to expedite the flow, and also it is important to maintain orderly flow, so that there is order in the operations. Both of these are important. Expediting helps in reducing the wasteful expenditure, and also orderly flow ensures that things are moving as per a proper order. Then once they prevent collisions and they expedite and maintain the flow, the next important task of air traffic services is to issue advice and information for the safety and efficiency in the whole air traffic system. Okay. And in case there is an incident, in case there is a requirement, they have to also notify and assist the appropriate organization in the search and rescue missions. So, these four in the order of importance are the objectives of air traffic services. Of course, in case of emergency, the last one, which is notifying and assisting appropriate organization, it may become a primary duty. You might require to make the whole traffic stand still and just give the help for the search and rescue. I am not saying that number 4 is the least important. I am just saying that this is the normal priority, because incidents and accidents are very few, but when they happen, they take the priority. To ensure that there is seamless connectivity between an aircraft from one particular airport to the other airport, and there is a continuous guidance and support available, we have to look at how the air traffic control is divided into various types, and responsibility for each area is allotted to a particular unit of the air traffic services. So, the first of them is the aerodrome control tower, sometimes also called as the airport control tower. The words aerodrome and airport are going to be used interchangeably, so they are the same. So, the aerodrome control is normally managed by a person or a group of persons called as the tower controller. Okay. So, every airport generally has a control tower or a control cabin. The tower controller at both the origin airport and the destination airport is responsible and concerned about the safe movements of the aircraft near and in the airport. Okay. Mainly, you can say mainly when the aircraft is on the ground. Okay. And I am not saying that the tower controller is not going to be concerned about anybody who is in the air, but the main responsibility of the tower controller is for the ground movement. Then we have the approach control, or also called as the terminal controller or terminal controller units, correct. These are units which are responsible for the movement of the aircraft during arrival and departure. Once the permission is given for an aircraft to initiate takeoff or to initiate landing, this particular control is exercised by the terminal controller or the approach controller. As I said, they are responsible for arriving and departing aircraft. So, at one point of time during the initial sequence, the control is passed on from the tower controller to the terminal controller, and similarly when the aircraft is coming into land, it is controlled by the terminal controller, and once the landing is allowed, when the aircraft lands, your control is passed on to the tower controller. And in between two airports, you have what is called as area control or the en route controller. So, the area control is responsible for aircraft movements in other controlled airspaces. Now, I will elaborate very soon what is meant by controlled airspace. Right now, you can just consider that once an aircraft has completed its takeoff and gone into the final climb, and now it is going to cruise to the destination, and before it actually comes in for the landing approach, during that entire period the aircraft movements are controlled by the area control or en route controller. And there could be, if for a very long route, in the figure that you see here, there is only one area control or one en route controller, but if it is a very long distance flight, you may be passed on from one en route controller to the other, to the other, to the other, several of them, as you enter more and more as you enter the airspaces of various other sovereign bodies or sovereign nations, you will be passed on. So, we will discuss all that in detail. So, broadly speaking, there are some air traffic controllers called as tower controllers who are looking and maintaining the orderly flow, expediting and avoiding collisions when the aircraft is on the ground. Then there are others called as terminal controllers who are interested more in channelizing the arriving and departing aircraft. They are the ones who decide which aircraft will be given permission to take off, which will be given permission to land, and how do we push maybe a departure between two arrivals or an arrival between departures. They are the ones who take care of that. They allow the operations to be done expeditiously, and the area control is the one that is giving the long term control guidance and information to the aircraft which are overflying. So, to meet this requirement, the air traffic system is broken into various units, and these are closely related to the ones that we saw. But remember, these units could be either the ones in the forefront or they could be behind the scenes. Now, the ones that I mentioned to you, the three of them, the aerodrome control, the terminal control and the en route control, these are all in the forefront, but there are three agencies or more which are also working behind the scenes. So, let us look at them one by one. Obviously, the aerodrome control tower, normally abbreviated as TWR or TW tower, as I mentioned, they will be looking at aircraft on the maneuvering area in the vicinity. And then you have approach control office or APP, which will be looking at arriving and departing aircraft, and there will be area control center or ACC, which will be looking at the en route or overflying aircraft. These are the ones in the forefront, but there are many ATS units which are behind the scenes, which work behind the scenes. So, there is something called as a Flight Information Center or FIC. This gives advice and information to pilots, and this is very important because the situation, the availability of navigational aids and the weather etc. at the destination, all of that is going to be not the same every time. So, when a pilot is about to board a flight and plan the journey, they have to be given advice and information. That is done in the FIC. Then you have what is called as ATS Reporting Office or ARO, where pre-flight clearances are given and the liaison is done with the other agencies. This is primarily done to ensure that there is a strong liaison between the defense agencies and the civil aviation authorities. So, technically speaking, every flight that operates under the control of a sovereign nation, they need to have what is called as air defense clearance. Okay. But since there are so many operations of commercial aircraft, specific clearance for each aircraft need not be given. There are many automated procedures to give the air defense clearance. However, at every major airport, and I can tell you from my own knowledge of the Mumbai airport, there are people from the defense agencies, mainly the Indian Air Force, who are available and are positioned at the airport to, and they keep monitoring the airspace to ensure that there are no rogue enemy aircraft coming in the guise of civil aviation and to do some damage to the country or to do spying over the country, etc. So, there is a ARO at every major airport, and they are the ones who give the pre-flight clearances. As I mentioned, these clearances are by default given for commercial operations, but any aircraft that is suspicious could be denied permission, and if there is a suspicious entry of any flying object within the airspace controlled by a nation, the ARO can liaison with the Air Force units and either send the military aircraft to investigate or to escort these aircraft, rogue aircraft, away from the airspace. And then you also have the Aeronautical Information Service or AIS, which is basically an area or a location or an agency where you get all aeronautical information. Whenever there is any change in operating procedure or non-availability of a particular aid or any operation of any other activity, for example, if there is an air show going on in a particular area, then a NOTAM is issued. NOTAM stands for Notice to Airmen. This is a formal communication to all the people who are concerned with that particular operation that there is an activity going on. For example, if suppose in some area there are some people who are operating a hot air balloon, okay, which is going to go up in the air. So, it is important for the people who are flying aircraft to know that there is some activity in this area, so that they are forewarned. As we say, forewarned is forearmed. So, this information normally, there are other reasons also. For example, when you are landing at a particular airport, the particular equipment may not be functional. So, unless you are informed in advance. So, in the FIC, of course, the pilots are given detailed information regarding all the things which are going to be relevant to that particular day and that particular operation. But the AIS is a very generic agency or a location or a unit where information regarding all the NOTAMs is placed. So, these agencies work behind the scenes, but they are equally important to ensure that the goal of ATS is being met. So, now we come to the three pillars on which the whole edifice of the air traffic services stands. The first one of them is the communication, the next one is the navigation, and the third one is the surveillance. So, communication, navigation, surveillance, which is normally abbreviated as CNS, okay, and generally the provision of services is called as air traffic management. So, the full acronym is CNS ATM. that becomes the entire edifice of the air traffic services. So, now let us look at each of these three pillars, what do they stand for and what do they involve and what is their importance. Starting with communications. Communications is very important because every flying object, every aircraft is operating within the realm of the geometric coverage of an area. So, it is important for everybody else to know, and there are these air traffic managers who are looking at the whole scenario. So, they need to talk, they need to communicate. So, communication is very important, but it is not just air to ground communication or ground to air communication. Communication generally is both ways, two-way generally. Okay. Some communication takes place also automatically in one direction, as we will see, but generally we have communication both ways. What most people are aware of is the air to ground and ground to air communication between the pilots and the air traffic controllers and vice versa, but it is also important to note that there is also inter-ATC position communication. For example, the communication between the area control and the approach control and the tower control, they also need to communicate with each other, they also need to pass on messages. Okay. So, this is happening at the same station. However, when there are multiple units operating in the neighborhood of each other at various cities, various locations, you also need to have communication between different stations. Okay. So, you need to have communication links established and working and reliable links between this station and the other station nearby, okay, between two area controls or this area control and that particular other location. Then you need to have ATC communication for emergencies. As I said, there could be instances, there could be an aircraft which is having an issue or an emergency, there could be hijacks which are of course very rare, but they do happen. So, there could be emergencies, and when there are emergencies, then there is a separate chain dedicated communication link for emergencies. There are hotlines available, and those need not be dependent on the normal communication channels which are used in normal situations. Similarly, we also have backup communication units available at all major airports using the pulse switch telecommunication network or PST, and the normal landline phones that you hear, or even the mobile phone communication system that we use. So, there is also a requirement for backup communication facilities available in case the communication system of the ATS fails, then the communication takes place through using the back. Of course, there is a limit to it. I mean, you cannot talk to a pilot using PSTN obviously, because they do not have the access to that. And then there is also ground to ground data communication between various units on the ground itself. Okay. They have to also share data, they also have to communicate to each other. So, communication is not just between the pilot and the ATC, but with many units happening at the same time. Navigation. We will have a separate session on navigation, on how aircraft are navigated, what kind of procedures are used, what is the philosophy of aircraft navigation in civil navigation, and also we will look at how the onboard instruments on an aircraft are provided with features to allow navigation. But generally, to have a look at what is navigation. In navigation, what you require is, you require positional information to the pilot. Where is the aircraft with respect to any reference in the air at any point of time? Now, you might say that why can't we use a magnetic compass, and using magnetic compass you can get the orientation or the radial in which you are flying, and you can get the magnetic heading and you can use it, but it is not adequate. There are many errors, and also there could be situations where there are disorientations, and so it is not sufficient. It at one point of time might be it was sufficient, but not now. So, the information that is required to be given to the flight crew members depends on in which flight phase they are operating. Of course, in each phase they will have separate requirements. For instance, when the aircraft is in en route flying, when it is flying overflying, not on the ground, not during takeoff and landing, but in mostly level cruise long distance flight, you require your current location, and that can be done using an instrument such as the non-directional beacon NDB, which has a unit called as the automatic direction finder or ADF. Okay. This was a very primitive and old fashioned instrument, and we will talk about these instruments in detail in our talk on navigation. Then you have more sophisticated equipment called as the very high frequency omni range or VOR, and there is one more equipment called as the distance measuring equipment. Many a times a DME is co-located with the VOR, so we call it as a VOR DME or a VORTAC. All those will come relate, but remember, when en route flying, what is required is your current position along the flight path that has been chosen. But when you fly on oceanic airspace, that means when you fly over a large swath of ocean, on the ocean it is very difficult to provide regular navigational updates, because in the sea it is difficult to maintain and to provide navigational information, because there are no instruments available as frequently as you have on the ground. So, there we depend mostly on the inertial navigation system, which is inbuilt on the aircraft, the INS system, or the global positioning system or GPS, which is the one we use for navigating our vehicles when we are on the land. When you come for approach and landing, you require a different kind of information. You have to be oriented towards the runway center line, and you have to be sure that you are coming at an angle so that you will touch the runway at the correct point, so that you can land within the runway distance available. For that, we have a dedicated instrument called as the instrument landing system, and again we will have a detailed lecture on the working and the features of a instrument landing system. Therefore, information regarding navigation is a function of the phase in which the aircraft is, and appropriate instruments are available to provide guidance to the pilots. Let us have a look at an example of navigation. So, information regarding what the aircraft intends to do is communicated by an airline to the air traffic management services using what is called as a flight plan. Flight plan is a document that mentions to the ATM agency what is the intention and what is the plan of action, and it contains lots of information. It is filed before each flight operation. Although you may have the same flight every day, you will have to have a special flight plan or a specific flight plan for each flight. It contains a lot of information which is useful for operation. For example, it contains aircraft identification information, the call sign of the aircraft or the number of the aircraft which is there on the tail of the aircraft. It talks about under what flight rules will it fly and what type of flight it is. We will see little bit later. It mentions about the number of type of aircraft that are going to be used. It talks about what is called as a wake turbulence category. Again, we will look at it little bit more detail later on. It will tell you what equipment are available on board. It will tell you which departure airport it intends to operate from. It also tells you the estimated time when it will leave. Of course, this time will be adjusted by the clearances given by the aerodrome controller, and then at what speed it would prefer to fly, at what altitude it will prefer to fly, what is the destination airport, what is the total time that will be expected to take to travel. In case there is a problem, where will you divert to the alternate airport or maybe more than one airport, how much fuel you have, how many hours can you fly with the onboard fuel, total number of people that are planned to be carried on the aircraft. Okay. Then what kind of emergency and survival equipment is available on this aircraft in case some incident happens, and many other information. So, this entire information which is required to be known by the air traffic management authorities for every flight is filed through a flight plan. In most airports or in most air traffic management zones, you need to file your flight plan minimum 2 hours before the departure. So, that is like a communication of your intention of travel, and then that flight plan gets accepted in the system, and once it gets accepted in the system, then the air traffic authorities know which aircraft are going to come at what time. Of course, they will decide which one will actually go. Rarely you will be able to operate the aircraft perfectly as per the flight plan. So, here is an example of a flight plan. You can see the blank format of a flight plan. This is the international flight plan. So, all the things which I mentioned are all listed here, you can see. And here is an example of a filled flight plan. All the information, like for example, what will be the route, what is the flight time, all information regarding the aircraft and the route is mentioned. So, this gets, normally we file a computerized flight plan. So, this information gets into the system automatically. Now, let us look at an example of how navigation is actually accomplished. So, I have taken an example of a flight from Mumbai airport, which is abbreviated as VABB, to New Delhi airport, which is abbreviated as VIDP. This is one of the busiest routes. In fact, this is the 6th busiest route all over the world and the busiest route in India. So, let us see how flights take place along this route. So, here is a map that I have taken from a tracking website, which tells about what path you will be taken. Notice that the flight path from VABB, which is here on the bottom, to VIDP, which is on the top, it is not a straight line. It has some, it is point to point. Okay. That is because the whole zone is concerned is divided into routes, and there are some reporting points at which information regarding the aircraft has to be communicated by the pilot to the reporting point below, and some of them are not compulsory reporting points. Okay. So, therefore, the path that you follow is not a straight line, and if we zoom into it slightly, you will see that to avoid congestion, there is a different line which is followed, or a different route which is followed for arrival and different route followed for departure. There is some area which is common. So, for example, when the aircraft, now BVB is the name of the VOR at Mumbai airport. So, when you take off from Mumbai airport, you proceed over this particular reporting point called Dotip to a place called Apano. Now, what are these places? These are basically names given to certain reporting points or stations which are theoretical in nature. Many of them will have an air navigation aid like a VOR located below it. So, when the pilot thinks that they are over Apano, they will inform the ATC, and the ATC will then tell them whether you are actually over Apano or you are drifting on one side. So, you can correct your orientation. So, from BBB you go to Dotip, Apano, then we go to border. Of course, there is a deviation here. Then there is a common route between border and PRA. PRA stands for a VOR called as Pratapgarh, which is a location near Allahabad, or now it is called as Prayagraj. So, PRA is a location where the pilot will also correct the position, and then you have this particular route, Idola, Gudum. Then this is the Jaipur, VOR, and from there it goes to Lasas, and then it goes to New Delhi. When it comes from Delhi to Mumbai, the departure is from VIDP, it goes to Deepas, then Asovo, and then Bidar, and then like that, and then again back, and then straight. Correct. So, the departure and arrival routes have been made different to avoid congestion at the airport, because as I mentioned, these are the busiest airports in the country. Now, this blue line represents the boundary of the what is called as the Flight Information Region, or FIR, which we will see very soon. The area below the blue line represents Mumbai FIR. So, aircraft flying in this area are under the direct control of the air traffic controllers operating from the Mumbai zone, and the area above the blue line in this figure represents the area controlled by the New Delhi FIR or Delhi FIR. So, aircraft which are in that zone are normally controlled by people operating under Delhi FIR. So, now we come to surveillance, the third pillar of air traffic management. So, here we just ponder and ask a question: what is the information that an air traffic manager needs when you are trying to do the surveillance of an aircraft flying in the air? Okay. So, basically what you need is, you need a consolidated real time picture of all the air traffic that is present in the airspace which is being controlled or managed, correct. All aircraft, all flying objects in the space that a person is maintaining or operating, you need a consolidated picture and you need the information in real time. This information is, it's interesting to know how is it provided. This is normally provided using various types of radars. Okay. So, there are these 4 types of radars. Okay. The first one on the bottom left is the Airport Surface Detection Equipment or ASDE. This is the radar dedicated for looking at the traffic on the ground, and we will talk about all of these radars one by one. These are the 4 main types of radars which are used for surveillance by an air traffic manager. So, let us look at now the radar for aerodrome controller who is interested in surface movement, that is the ASDE. This is a very expensive equipment, so you will not see it at every airport. You will need an ASDE, or you can justify an ASDE only at those airports where there is a huge amount of movement. So, in India for example, Mumbai airport has a lot of surface movements and so has Delhi. So, ASDE is the equipment that you will find only at such airports. This particular radar is looking only at aircraft, vehicles and people on the ground. This is an example of the imagery that is available to the aerodrome controller on a ASDE equipment. Then moving on, let us look at for the approach controller. The approach controller is interested in locating arriving and departing aircraft. So, they need what is called as an airport surveillance radar. This radar is able to monitor the air traffic within about 60 nautical miles or approximately 120 kilometers or little bit less from an airport, which is the location where arriving and departing aircraft generally are, because after that they will go to the area controller. Okay. So, you have here primary and secondary radars. You can see the close up of a primary radar, and you can see such radars at the airports. They keep rotating and they provide, as I mentioned, information regarding the aircraft located within around 60 nautical miles. They may be mounted at some height so that they can clear the obstacles near the airport and look far away. And now let us look at the radar suitable for the area controller who is interested more about the aircraft which are away from an airport, approaching to or going towards the other destination, going towards the destination. Okay. This is the Air Route Surveillance Radar, abbreviated as ARSR. This radar, which looks something like this, kind of a football kind of a thing mounted over structure. This has got a much larger range. It has got a range of around 220 nautical miles or 440 approx kilometers away from an airport, and that would be the approximate area which is under the control of an area controller. After that, we will have to give it to the next area controller who will probably have a similar radar covering their area of operation. Okay. Then you also have a secondary surveillance radar. Now, the ARSR which I showed you in the previous slide, it only detects the bearing or in which direction you are coming from. That is not enough. Okay. So, bearing basically means an aircraft is present and what you need is more information about the aircraft. So, this is done, the working of the basic radar is using the detected reflections of radio signals. However, you also need extra information. So, the secondary surveillance radar or SSR, it requests additional information from the aircraft. For example, what is the identity, because there will be many aircraft at the same on the same route at various altitudes. So, just their presence is not enough, we need to know what is the identity. So, each aircraft has got a ID which will be then flashed on the SSR along with the aircraft as a label, and we also want to know what is the altitude at which they are, correct. So, this particular information is communicated to the SSR by the aircraft using what is called as the transponder. There is an onboard instrument called as a transponder. ATC transponder. That transponder, when it is queried or interrogated by the radar signal, it sends the information regarding the identity of the aircraft and also its height. Now, if this transponder is not working or if it is switched off either accidentally or intentionally by a person who wants to hijack the aircraft, then information regarding which is the aircraft and what is the height will not be available. So, therefore, it is not very easy to manually switch off the transponder. Okay. It is not very easy. In fact, there is a special code which the pilot can send through the transponder informing the ATC that there is some emergency like a hijack or some other issue. By dialing certain numbers, you can actually use the transponder to communicate the information to the ATC on the ground. This gives you more positive detection of bearing, and this is better than just to have a ARSR. So, in 1990s or beyond that, most of the SSRs, they were replaced by monopulse SSRs. Now, monopulse SSRs are basically advanced forms of SSRs. What they do is they avoid two problems. One is called as garbling, the other is called as fruit. Now, what is garbling? If there are many aircraft which are at the same or similar location, far away from where they are, they will all appear very bunched together, correct, and you will not be able to actually know their if you do not have monopulse SSR, it will be difficult to make out who is responding because there will be multiple responses. So, you will get a garbled input, and fruit is basically some kind of a pattern gets created in the radar when you have many aircraft far away, and that pattern gives the look like a fruit. So, that is, so these things are avoided in an MSR, in an MSSR these things are avoided, and therefore, you have more direct and specific information regarding the availability of the aircraft. So, hence the separation between them, which was earlier minimum 10 nautical miles, can be reduced to 5 nautical miles, thus allowing larger throughput, thus allowing larger throughput. So, this is so currently most of these radars for the area controller, they are the MSSRs. So, summing up, let us list down what are the responsibilities of the air traffic controller. First is they are supposed to provide information. In some cases, provision of information is mandatory and the instructions of the ATC cannot be ignored by the pilot except for one situation where the TCAS signals, when a pilot receives an alert from a traffic collision and avoidance system called as a TCAS, that is the only situation in which today a pilot is permitted to disregard the ATC input. Other than that, in all situations the pilot is duty bound to follow the instructions given by the ATC. The second important job of the ATC, I am going to use the word ATC and ATM again interchangeably, because current usage is air traffic manager, because they are not only controlling, they are managing the traffic, but because of habit we sometimes just say ATC, because that is what they were called earlier. So, I will be using both ATC and ATM interchangeably. So, the other work of the ATCO is to determine the position, the location of the aircraft, then they are supposed to issue clearances and also clear the information, plus they are also required to coordinate the clearances between various units. So, when there is a handoff from one FIR to the other, or there is a handoff from one control station like approach to the area control or from approach to the aerodrome control, that is called as coordinating the clearances. So, these are the four main tasks of an air traffic manager, and the whole exercise that they do revolves around providing these four types of information. Now, I mentioned to you that there are certain rules of the air. Actually, there are just basically two rules of the air. you could to understand the meaning of rules of the air, first you have to understand operating conditions. There is one condition called as a visual meteorological condition. This is a condition in which there is enough visual information available for a human pilot to be able to detect obstacles or other aircraft and take a decision. So, but there could be scenarios when the conditions are not suitable for VMC, because it could be that the visibility is not good enough, not up to a particular distance. Then there could be clouds present in the path, and the clouds could be at some distance and also at some altitude. So, if you are operating in weather conditions which do not permit VMC, and these are defined properly, then you cannot fly under what is called as the visual flight rules. So, when you have VMC conditions favorable, then you can say that the flight can be conducted under VFR. VFR is visual flight rules. In visual flight rules, pilot is supposed to maintain the VMC. So, the pilot is responsible. Okay. Then if you are not able to do because of poor weather, or you are in a very congested, very busy airspace, such as what I will show you in the next few slides, then you fly under IFR or the instrument flight rules. In the instrument flight rules, or whenever there is an operation or a flight conducted under IFR conditions, it could be in perfectly good weather, everything is visible, but because of the tremendous congestion, you will be forced to fly IFR. In IFR conditions, pilot need not conform to VMC, it is the responsibility of the air traffic manager to provide the separation and to give the instructions. Okay. There is one more category called as special VFR, which is normally applicable to helicopters, etc., and also nighttime flying aircraft, and visibility is very good in the night. That is a special case, so it is called a special VFR, but generally you have flights in VFR, flights in IFR or special VFR. So, let us see now how this airspace over any sovereign country is classified. Now, before that we need to understand that the ICAO, which is a body of the United Nations, it has come up with certain harmonization of operational rules, and the whole world has been divided into various flight information regions, and each country which is able to provide air traffic services is allotted a particular area over which any aircraft which is flying, it is their responsibility to provide the required air traffic management services. So, these are called as FIRs. In India, we have 4 FIRs, or you can say that there are 4 FIRs whose territory can or exceeds the boundary of the country, but we have been given the responsibility of communicating with other flights and to provide them the navigation and ATM services. So, the 4 FIRs in India are the Delhi, Mumbai, Chennai and Kolkata IFRs, as you can see in the map. So, you can see that the Delhi FIR is completely over land and it is only covering the area which is under the sovereignty of India. But Mumbai FIR not only covers the area of the western part and the central part of the country, but also a large area over the ocean. Okay, right? There is a boundary of between Seychelles FIR, Mauritius FIR and Malay FIR. Okay. Then you have Chennai FIR, which also has some portion covered over the land of the country, but also certain areas in both sides and oceanic airspace. And then you have the Kolkata FIR, which provides the services over ocean as well as the eastern part of the country. So, the 4 FIRs in India, let us look at. So, first of all it is Delhi. So, the name of this is VIDF, these names are given by ICAO. It has a continental coverage or land coverage of 10.2 into 10 power 5 kilometer square. Okay, so 10.2 lakh kilometers or about 1 million square kilometers. Oceanic airspace is absent 0, as you can see there is no ocean here, it is all landlocked. The total is 10.2. Moving on, if you come to VABF, which is the Mumbai VFR, Mumbai FIR, here we have the similar area 10.1 into 10 power 5 or 10.1 lakh square kilometers, but more than 3 times of that you have the oceanic area which is shown here 37 lakh square kilometers. So, total area covered by the Mumbai FIR is 47.1 lakh square kilometers. Then you move to Chennai VFR, again as I mentioned to you, it has got around 14.3 lakh square kilometers of coverage over land over continental India and 10.5 over the ocean, total 24.7. And finally, we have the Kolkata VIFR. Kolkata VIFR mostly covers the land area 14.7, but it also has this 3.8 lakh square kilometers oceanic area. So, the total area is 18.5. So, by far Mumbai is the largest FIR in India, followed by Chennai, followed by Kolkata, and then finally Delhi. Now, there are some challenges in servicing the FIRs in India. Let us have a look at these challenges. First thing is, more than half the space allotted to India is oceanic airspace, and as I mentioned, in oceanic airspace it is the support available from the instrumentation or from navigational aids is minimum. In fact, there is a shortage. So, therefore, communication takes place mostly by repeaters or using the high frequency radio. Now, high frequency radio has larger range, but unfortunately it has got a lot of clutter. So, it is very difficult to really figure out the signals. So, you need experts, experienced people who can listen to that communication and extract the information and pass it on. Okay. Secondly, substantial airspace coming under these 4 FIRs is not available for civil, commercial or civil aviation, because these include large swath of airspace which is defense airspace or military airspace or restricted airspace or no fly zones. In the northeast, which is mainly coming under the Kolkata FIR, you have a very large areas which are difficult to reach, hilly terrain and also inhospitable. So, provision of instrumentation, maintaining those instruments, ensuring that they are not pilfered, ensuring that they work requires substantial effort and cost. Then we have inadequate and unreliable support infrastructure available. This is not true in the major urban areas, but if you look at small airports or locations, sometimes the backup support may not be that good. Okay. There could be interruptions in power supply, there could be interruptions in communications. So, therefore, backup systems have to be created and maintained. Then to cover such a large area which is more than 100 lakh square kilometers, the ground based navigation systems, although there are many available, but they are still considered to be insufficient and they need constant upgradation. Plus, whenever you have terrain conditions, the performance can be affected. So, we have to be very careful about it. Okay. Finally, because these instruments are expensive and they require periodic calibration, they are very expensive to maintain. I am not saying that other FIRs do not have these challenges. I am sure countries similar to India would have similar or even more difficult challenges, but these are some of the challenges which have been identified for maintaining the FIRs over India. So, now let us see how the airspace is organized. Okay. The entire airspace over a sovereign country is not the same. There are various types of airspaces. Okay. So, there could be a controlled airspace and there could be a, now this controlled airspace is regulated and controlled by the ATC services, and it consists of various special airspaces such as prohibited airspace where you are not allowed to go, restricted where some aircraft can go, military use where you can go but at your own peril because mostly it will be dangerous to fly there. Then there are special use airspace, there are some airspaces and there are so many others. Okay. But there is a huge area which comes under the uncontrolled airspace, where there is no authority or control by the ATC authorities. Pilots maintain the VFR minima. So, it is not that over the entire sovereign zone controlled by India you have ATC available. No, ATC is available only where it is required, and as and when traffic starts increasing or building up, more and more areas can be converted from uncontrolled airspace to controlled airspace as the requirement may be. The categories go from letter A to letter G, in which A to F is controlled airspace and G is the uncontrolled airspace. Now, as we proceed, so here is a picture which shows you roughly how various classes are there. So, you can see the class A airspace is the entire airspace 18,000 feet above mean sea level, that is flight level 180 to flight level 600. This entire airspace is the class A airspace. Okay. Then you have class B, which is located in a particular area where air traffic authorization is required. Then you have class C, again class D. You can see this class G shown in the pink color is the airspace where you do not need direct air traffic control, because this is the uncontrolled airspace. So, this graph is mainly meant to show the airspace in which drones can be operated and what kind of airspace they are allowed to operate. So, as a letter of the airspace increases from A to G, you have lower and lower ATC control and more responsibility of maintaining separation is passed on to the pilots. So, A is the most critical and G is the least critical. So, let us see, if you look at class A airspace. In class A airspace, even in perfect weather conditions, you are going to fly only in IFR. So, all flights are subjected to air traffic control. Anything that flies in class A airspace definitely has to be under the direct control and jurisdiction of the corresponding air traffic control agency. All flights are given separation information from each other proactively by the air traffic controller. In class B airspace, certain things will be reduced. So, now in class B airspace, you can fly in IFR or in VFR. So, when you fly in VFR, that time it becomes possible for the pilot to maintain the VMC, correct. You go to class C airspace, you have same as class B, but now separation is maintained. But between whom? If there are two aircraft flying in IFR, or if there is one IFR and one or more VFR, separation is given in class C by the ATC. Okay. If there are flights which are VFR and there are other flights which are VFR, then we do not give them separation information, we only give traffic information, that is class C airspace. So, if you are an aircraft flying under IFR in class C airspace, you will be given the information for separation from other IFR aircraft and other VFR aircraft. If you go to one step lower, class D, you have the same thing as class C, but now you are only worried about IFR to IFR flight. If any flight is VFR, we do not worry about it. We only give traffic information to IFR versus VFR and VFR versus VFR. So, you can see slowly the control level is reducing. Coming down to class E airspace, it is same as class D, except IFR flights are subjected to ATC and separation for other IFR aircraft, and all flights receive ATC information as far as possible. Notice, it is very important. Above this category class B, class C, it is important and mandated to give information, but here it is as far as possible. Going one step lower, in class F, only IFR flights receive information. We do not worry about VFR flights at all, and we have a flight information service for all flights on request basis. And class G is uncontrolled airspace. Here flights will receive information if requested from the FIC, FIS. Now we come to the last and the most important part on what are the norms which are used by the air traffic managers to ensure the minima between the aircrafts are maintained. So, there could be many ways of doing it. One way is to do through vertical separation. So, if you are operating an aircraft above flight level 290 earlier, the minimum gap or the altitude separation was 2000 feet or 600 meters approximately between two aircraft flying in opposite directions, but this was above flight level 290, and below 290 the gap, the altitude was 1000 feet. This is old story. So, if you are flying below 29,000 feet, the minimum gap between the two aircraft will be 1000 feet, and above that it will be 2000 feet. However, there was an initiative to reduce this called as the reduced vertical separation minima. When that is introduced, then the spacing also reduces by 1000 feet. What I mean is the minimum spacing reduces to 1000 feet even when you operate above flight level 290. So, let us look at that in some more detail. RVSM is something, so this is a non-RVSM operation, it was earlier. So, you can see that from 290 the next level will be only 310. 310 stands for 31,000 feet. When you look at flight levels, what you do is you remove the last digit and replace it with 1000 feet. So, 290 means 29,000 feet, 410 means 41,000 feet, and aircraft normally do not fly above 41,000 feet normally. The most common flight levels are 330 and 350 for the cruising flight, or even 370. Now, in 1958 RVSM was introduced, and this RVSM allowed 6 additional levels of operation. So, now the vertical separation minima has reduced to 1000 feet, okay. But it does not come free of cost. You have to have certain equipment and training and facilities. So, what do you need to have in the aircraft to be able to be RVSM qualified? You need 2 independent altitude measuring systems, not just one. You need an SSR altitude reporting transponder, so that your altitude is proactively communicated to the air traffic manager. You need to have an altitude alert system, so that in case your altitude changes, you need to get a proactive alert. You need to have an autopilot, and also there has to be a flight crew approved training program or the operating specs approval. Okay. Then there are some monitoring requirements, that is 2 aircraft every year, or after operating for 1000 hours, or 2 years, So, these are requirements specified for monitoring the aircraft. So, either you have monitoring done and then certification is then approved for operation on RVSM. You can also separate the aircraft horizontally. So, if you have an instrument called as a non-directional beacon, which is actually a primitive instrument, old instrument, then when you have aircraft at the same altitude approaching or going away from a navigation fix. So, there could be one aircraft which has gone over the NDB and proceeding further, there is one aircraft approaching the same NDB. They have to have a minimum angle of 30 degrees between them, and the distance from the instrument has to be minimum 15 minutes of flight or 28 kilometers. Okay. However, a slightly more advanced equipment is a VOR, very high frequency omni range. If you separate using VOR, then the radial can be reduced to 15 degrees. So, lesser radial separation is permitted because you have a more sophisticated equipment, but the distance requirements remain the same. Then one could have lateral separation. So, aircraft flying at the same route at the same level, one behind the other, we need to maintain a flight time of at least 15 minutes between two aircraft on the same flight level in the same direction on the same route. Okay. Now, if you have navigational aids on the ground which permit more frequent updates, then this could be reduced to 10 minutes of flight instead of 15 minutes of flight. And when you come to the terminal area, or when you come to the area where you are approaching and landing, or just after climbing after takeoff, there, because you have better instrumentation coverage, you have the radar available to you, therefore, you can have the gap of minimum 5 minutes. But this is for aircraft not ascending and descending, this is for the aircraft which are at the same level, one behind the other on the same route. Now, when you have nav aids, you can permit lower separation. So, for example, I told you 2 aircraft 15 minutes minimum, but if there are navigational aids along that route, it could be reduced to 10 minutes. Similarly, if you have one aircraft crossing the path at the same altitude, then you need to have a gap of 15 minutes, but if both of them have navigational aids before and after their routes, then you can reduce the time to 10 minutes. Another important thing to be kept in mind is separation between two aircraft when they are departing or when they are arriving, to ensure that the wake of one aircraft does not affect the wake of the other, does not affect the other aircraft substantially to cause a problem. So, for that certain categories have been created. Okay. So, as per one classification, all aircraft which are having a maximum takeoff weight below 7,000 kg or 7 tons are considered to be light aircraft. Between 7 tons to 136 tons are medium aircraft. More than 136 tons is heavy aircraft, except some which have a huge wake behind them. And then you have super heavy aircraft which are like Airbus A380 or AN225 or AN125. Sadly, AN225 was lost. There was only one aircraft available in the Ukraine-Russia conflict. This aircraft was damaged and it is no longer available. Okay. But we know that some of the engines of AN225 are being recovered and they can be used for the powering of the AN125. But one more category was introduced between medium and heavy, and that was called as a large category. Now, the items that you see in black color are basically the categories given by ICAO, but FAA introduced one more category called as large. So, light, medium, large, heavy, super, and large category basically is 19 tons to 140 tons. Okay. Now, there are some exceptions. Boeing 757, whose all-up weight is 116,000 kg. So, actually it should come under medium category, it should come under large, it should come under the large category, okay, because the weight is 116 tons. However, it is considered under heavy category because its wake was found to be very large. So, after a few years it was realized that this particular, and gap, the separation was given between all these aircraft. Then it was realized that it was leading to a lot of congestion at the airports, because if you have to keep a long gap between two arriving aircraft, the throughput of the airport reduces. So, wake turbulation recategorization, or called as recat, was taken up both by ICAO and by FAA, the two agencies. So, in the USA, where the FAA rules are operating, there were different approaches. In the European Union, where mostly the ICAO rules operate, they had different approaches. So, phase 1 of recat was launched in the US in 2013, where based on the takeoff weight, liftoff velocity, wingspan and the strength of the trailing vortex, categories were created. So, they created something like super, ultra heavy, lower heavy, ultra light, lower light and small. So, they had these 6 categories. Okay. Phase 2 was done in 2014, where they introduced one more category, where they said, okay, let us do separation based on specific pairs, Like when there is a A321 behind Boeing 747-100, what is the separation needed? Rather than giving it blindly, let us do it aircraft to aircraft basis. Phase 3 was launched in 2016, where the atmospheric conditions were also factored in while deciding the separation minima. In the EU, the RECAT 1 was launched in 2016, where the categories were light, ultra medium, low medium, light, upper medium. Let us record it once again. Categories were light, upper medium, lower medium, upper heavy, lower heavy and super heavy. This was based on extensive database which was created by looking at the aircraft data. Then the RECAT 2 was launched, same 6 categories as you saw, but separation is based on specific pairs, just like we had in the 2014 phase 1. Then in RECAT 3, we looked at real time data to decide the separation. Okay. And during headwind, we realized that if there is a headwind, if the air is coming from the front, then the vortex gets dissipated very quickly. So, lower separation was given. If there is a tailwind, air coming from behind, then the vortex tends to persist for a longer time. So, the separation time was increased. All these are attempts to optimize the minimum separation between two arriving and departing aircraft, or two arriving aircraft or two departing aircraft, so that the throughput of the airport is not compromised. Okay. That is the reason. Then you have distances. So, what are the distances? If the aircraft is a heavy aircraft behind a super aircraft, the separation has to be either 5 nautical miles, or if it is a medium aircraft behind super aircraft, it will be 7 nautical miles, etc. So, you can see that distances have been given. Minimum distance between two aircraft, depending on which is leading and which is trailing, is given. Sometimes we also look at time based minima. So, for example, how many minutes should be an aircraft delayed? So, if you are flying a super aircraft, super heavy aircraft, then a light aircraft will only be allowed 4 minutes after the flight of super heavy aircraft, because it has been found that 4 minutes is a huge time. So, all these RECAT categories, they have reduced these by creating more categories. Now, if you want to increase the airspace capability, you have to look at ways of improving it. So, one way is, if you look at the conventional separation, there will be one layer of lateral separation and certain layers of vertical separation. But what you can do is, you can introduce like this. In between, you can introduce some more aircraft and you can create more space in the aircraft by creating separation. Let us now see how an airspace configuration is shown in the navigational maps. Okay. So, in some locations you may have one small control zone around an airport and a larger control zone. These oval paths that you see are the holding tracks, where the aircraft is made to hold before it comes into land. So, such a configuration with one small control zone inside a bigger zone is shown on the charts like two concentric circles with a point, right. But you could also have a situation where there are two airports under the same control zone, and here there will be different holding stacks at both the airports, and there will be a control zone. So, this will be shown by one bigger circle and two smaller circles, or you can see here two pillars. That is how it will be shown in the charts. Sometimes you may have many routes from where aircrafts are coming in, and then there are 3 small airports. So, they will be shown like this in the charts. Or you could have a situation where there are also certain other airports which have paths that go. So, there are all kinds of configurations which are used, and these configurations are then depicted into the maps accordingly. The airspace also has got certain regions. There is a FIR, UIR, okay, one could classify them. So, I think these are details which we will not like to get into. So, thank you for your attention.